Hi everyone. I'll be explaining this problem called interesting ratio. Well, in this problem, you're going to be given a value n. This, have a look at the constraint here. It's up till 10 to the power 7. Um, well, what you're going to have to do is you're going to have to output the number of pairs that you can make out of this limit of n, um, and you have to really uh, make the pair in such a way that that pair's LCM divided by that pair's GCD would always be equal to a prime number. Always have to be a prime number. You have to calculate how many of these pairs are available inside the value n, and also you need to fulfill another condition where you see the pair value. The pair value, if it's a comma b, then b has to be greater than a. Now, okay, so let's take a look at an example. If n is equal to 10, the answer would be equal to 1. So there would be 11 possible pairs that would result in having this condition, fulfilling this condition, meaning their LCM divided by their GCD would result in a prime number. Now, as the value of n is really huge, it's 10 to the power 7, we cannot just possibly go through each and every pair and then calculate whether their LCM divided by their GCD is equal to a prime number or not, right? It's huge. N squared would, cross the limit. It's going to give me time limit exceeded. Instead, what we can do is think about it with the perspective of the prime numbers. Think about it not in the perspective of the pair, but with the perspective of the prime number itself. Why am I saying that? The reason I'm saying is that, you see, the number n might be bigger. It's 10 to the power 7. But up until 10 to the power 7, you are not going to get huge number of prime numbers up until that point. The prime numbers frequency is not that bigger, if within this limit. So that's a point in our favor. Now, another observation that I want to share with you is imagine two numbers. Let's say, what are we going to do? Let's say a number, let's say 4, and 8. Okay, let's say a pair number. This is a pair of A and B. Okay, we've got 4 and 8, and if you can analyze one thing, is that you would see that 4 times 2 would result and give me the value 8. Here, the value 2 is actually a prime number, right? And now, interestingly, also, if you take both of these numbers LCM, you're going to get 8 divided by, if you take both of their GCD, it's going to give you 4. And more interestingly, when you say this is the LCM divided by the GCD, it's going to give you that prime number right away. So we can actually observe a pattern here, which is if there's two numbers, between a pair, one you see A and B, and if you see that if the bigger number is divisible by the smaller number of that pair, and that divisor itself is a prime number, then I can also guarantee that these two numbers LCM divided by GCD would also result in that same prime number. Now that is a core observation that we need in order to solve and come up with a solution. Why it's going to give us. As I can actually claim something like that, I would traverse all the possible prime numbers, and what I would do is simply for each and every prime numbers, as the number of prime numbers are much less, so I could just easily traverse them. I could utilize the sieve technique to pre-compute all the possible prime numbers and then traverse each and every one of them, and then for each and every one of those prime numbers, I will try to calculate between the value from 1 till n. I will try to calculate exactly what is the maximum value that I can reach, which if I multiply with that number, with that prime number, I will get the value b, which is the maximum of that pair that I talked about. What I mean by, I'm saying that, let's take this 2. What do you think is the maximum value here? I think it's 5. 2 times 5 could be the maximum b value. 5 times 2 is 10, and then if you do 6 times 2, it's 12, so it's crossing the value in here in this example. So for 2, the result would be 5, so it's the maximum 5 that can arise. What I mean by the maximum pair, sorry, I think it's A. So 5 times 2 would be 10, so maximum pair for with respect to 2, with respect to multiplying with this prime number 2 with 5 would give us 10. Similarly, this is the maximum. Now you could do the same thing, so you have like 5 possible pairs like that, One of the possible pairs was this. The second one would be 4 times 2, 8. And then 3 times 2, 6. 2 times 2, 4. 1 times 2, 2. You get my point, I hope. But we don't need to actually utilize the pairs. We just care about the number of pairs that we can get. And for this prime number 2, we have 5 possible pairs such. Similarly, for 3, we also calculate that. Let's take a look at it. 3 by 3, 9. 3 by 4. Okay. Let's see. For 3, I think it's going to be 3 by 3, 9, and then 4 by 3. No, I think for 3 we're going to have 3 possible pairs. So for 2, I'm getting 5 possible pairs. For 3, I'm getting 3 possible pairs. And then for 5, let's see, what do we get? 5 for 5. So for 2, I get 5 of those pairs. For 3, I get 3 of those pairs. Just erase them. So it's going to be a little bit clearer, I think. Okay. Good. And for 4, actually, the next prime number was 5. So for 5, I get 2 possible pairs. Why is that? 5 times 2 is 10. 3 times 5 is 15, crossing 10, so I don't care about it. So for 5, I'm getting 2. And for 7, how much am I getting? 7 times 2 is 14. It's crossing 10, so I've got only up until 1. So I've got 1 pair. Now, if you sum them, you're going to get the answer. 8, 9, 10, and 11. 11 possible pairs. That's how you get the answer. Now, the big question is, again, I'm saying, for each and every prime number, what will I try to achieve? I will try to achieve the maximum power, the maximum pair that you can satisfy. And if you somehow find that maximum pair that lies within the range, then you know that the values before, they also satisfy with that prime number, as I've said it here. before. I've said it before. So exactly that's how you're going to run for each and every prime number that satisfies within the condition. And you just add them like that. Just like that. Now the big question, exactly how are you going to traverse and try to find out that maximum pair for each and every prime numbers? You're going to apply binary search. That's it. That's how exactly what you're going to do. And if you do that, you're going to, give a solution, give an efficient solution that's going to solve it within n log n complexity. With the addition of sieve precompute n log n, so it's more like it. For each and every prime number, you're going to do a binary search. Find out that maximum pair, and you have the answer. So if I take a look at the code section, I think you're gonna understand more. Let's see. Okay, so here we are. The sieve part, we're gonna apply sieve to try to find out all the possible prime numbers up until 10 to the power 7. We're going to track them for each and every test case. We're going to take the n, we're going to take the prime numbers, we're going to traverse for each and every prime numbers, and we're going to also see if it lies within the range, and then we call a solve function. That solve function, what it does, for the range 1 till n, okay, it takes the prime number, it's going to provide you that how many number of pairs that it satisfies the condition of primes. I mean, what I said, like the LCM divided by GCD is going to get prime numbers. How many pairs are we going to calculate here? We're going to do that using the binary search. We're going to find out the maximum possible pairs, and you see that's the range. We're going to take it, and you see we're checking whether any of the numbers, if it crosses the maximum R. Max R is actually referring to the max range here. If it's not, I'm always trying to track out the maximum values, the maximum range, the maximum pair, you could call it. The maximum pair is A. This should have been A, actually. That would have been much more understandable. But anyway, this is that value, and it's actually corresponding to, if I call for 2, let's say 5. It found out that it's 5. So up until 5, I have the 5 possible pairs that I can get. If you want to see one pair, okay, one possible pair is 5, and 5 times 2 is 10. Another pair can be 4 and 8, blah blah blah, and so on and so forth. So that's the part. That's how I actually came up with this solution. Thank you very much for watching up until now. I really appreciate it. So, and I hope you enjoyed the solution. Thank you very much.